Question number 38 from GATE 2018 Civil Engineering afternoon session is discussed here. Question is, a 6 meter long simply supported beam is prestressed as shown in the figure, and the beam carries a uniformly distributed load of 6 kN per meter over its entire span. So UDL is given. If the effective flexural rigidity, that is EI, equals to 2 into 10 to the power 4 kilonewton meter square, and the effective prestressing force is 200 kilonewton, the net increase in length of the prestressing cable is to be found out. So if we just look at what is given, so length of the beam is given, that is 6 meter, uniformly distributed load, that is W, 6 kilonewton per meter is given. Similarly, effective flexural rigidity, that is EI, equals to 2 into 10 to the power 4 kilonewton meter square. Effective prestressing force P equals to 200 kilonewton is given, and eccentricity is also given, that is 50 mm. Now to find out net increase in length of the prestressing cable. So how to approach to this particular problem? Student has to calculate properly. He has to solve this particular problem. Difficulty level, we can say it is difficult, since he has to recall the particular formula and solve it properly considering all the units. So actually there are two cases. The first one is to find out the slope due to prestressing force. Now if we just see this particular diagram, now here slope due to prestressing force is to be calculated. Now how to calculate that? The slope due to prestressing force, the formula is P L by twice EI. So here P is known, E is known, L and EI, all known parameters. So we have to insert, and accordingly 200 into 10 to the power 3 multiplied by eccentricity, that is 50 mm, and length, that is 6000 mm, 2 into 10 to the power 13, we are converted in terms of Newton mm. So theta 1 finally will be calculated as 1.5 into 10 to the power minus 3. Now theta 1 here is negative due to the upward movement. Similarly, we have calculated the case 1. For the case 1, slope due to prestressing force we have find out. Now the next one, the slope due to UDL, that is uniformly distributed load, is to be calculated. So slope due to uniformly distributed load can be given as WL cube by 24 EI. So here again the known parameters are W, L and EI. So if we just insert the values of W, L and EI in terms of kilonewton and meter, so we will get theta 2 as 2.7 into 10 to the power minus 3. So finally we will have to calculate net slope. We have already calculated the slope due to prestressing force and slope due to the UDL. So finally net slope of the beam so will be equals to, we have to add this to theta 1 and theta 2, since we already discussed that theta 1 is negative due to upward movement. So theta 1, that is 1.5 into 10 to the power minus 3, and theta 2, that is 2.7 into 10 to the power minus 3. So that is coming out to be 1.2 into 10 to the power minus 3. So net increase in length of the prestressing cable, so that will be equals to 2 into eccentricity multiplied by net slope of the beam. So eccentricity, since prestressing cable has eccentricity, so that will come into picture, and net slope. So if we just insert these two values, 2 into eccentricity multiplied by total slope, net slope, so that will be coming out to be 2 into 50 eccentricity, then theta is calculated 1.2 into the power minus 3, and finally we will get 0.12 mm. So that is the net increase in the length of the prestressing cable. So this is how this problem is to be solved. Slope due to prestressing force as well as slope due to uniformly distributed load. So two slopes are to be calculated. Then we have to calculate net slope and finally net increase. So that will be multiplied. We have to multiply it by eccentricity. And finally we'll get 0.12 mm, that is the net increase in length of the prestressing cable.